Have you ever thought about this? Why can a graphics card be dozens or even hundreds of times faster than a CPU and drive the entire AI industry crazy? Many people would say because GPUs have more cores, but that sentence only scratches the very surface. Because what's really scary about GPUs is not that they're faster. It's that from the very beginning, they're not the same kind of machine as a CPU. The goal of a CPU is to be smart. The goal of a GPU is to do 1 million simple things at the same time. Today, let's tear open a GPU, see what it really is. Why it can render games, train AI, and even change the entire computer world. Let's start with the CPU. A CPU is actually a lot like a top-tier engineer. It's very smart. It's good at decisions, branches, logic, and judgment. For example, in code, you write, if the enemy's HP is less than or equal to 0, drop loot. Otherwise, keep attacking. CPUs are naturally good at this kind of thing because real-world programs are full of if, else, while function calls. The CPU is designed for this kind of complex control flow. So inside a CPU, there are a lot of very expensive things. Branch prediction, superscalar execution, pipelines, cache systems, out-of-order execution, etc. It thinks like crazy. What's the program likely to do next? How to prepare data ahead of time? How to avoid stalling? The CPU is like an extremely smart, fast-reacting decision machine. But here's the problem. What if now you're not asking the CPU to solve one complex problem, but instead process a million almost identical problems at the same time? For example, every single pixel on the screen. Imagine this, you're playing a 3D game. Screen resolution is 1920 by 1080. That means more than 2 million pixels on the screen. And the game is dynamic. Assume 60 frames per second. Then the GPU has to process over 100 million pixels every second. And each pixel has to calculate lighting, shadows, materials, reflections, color blending, and even anti-aliasing, ambient occlusion, particle effects. If you ask the CPU to do this, the CPU would go crazy because the CPU would work like this. Okay, first pixel, then second, then third. It's too smart. Too smart for this kind of repetitive labor. So we need a completely different kind of machine. It doesn't need to be very smart. It just needs to be able to work at the same time. And so the GPU was born. The CPU's way of thinking is, how do I solve this problem? The GPU's way of thinking is, can I copy this problem 1 million times and solve them all together? That's parallel computing. That's the core philosophy of GPUs. The CPU is like a Michelin star chef. One person makes every dish very refined, very complex. The GPU is like a super efficient assembly line factory. 1,000 people, each doing just one action. Some only chop vegetables, some only add salt. Some only plate the dishes. Some only plate the dishes. None of them needs to be very smart. But together, the throughput is insane. This is also why the inside of a GPU looks nothing like a CPU. A CPU might only have 8 cores, 16 cores. Inside a GPU, there are thousands of compute cores. For example, many of NVIDIA's GPUs have thousands of CUDA cores. Each individual core isn't strong, but they can work together. So what does the inside of a GPU actually look like? Many people are shocked the first time they see a GPU chip diagram. On a CPU chip, the cache is huge, the control logic is huge, all kinds of complex structures take up a lot of area. But a GPU, almost all compute units, because it doesn't want to think too much. It just wants to compute like crazy. Inside a GPU, there's something called an SM streaming multiprocessor. You can think of it as a small compute factory. Inside, there are many little workers called CUDA cores. Each worker only does very simple calculations, like color equals light times material. Then the GPU will launch tens of thousands or even hundreds of thousands of threads at the same time. Not just a few threads, hundreds of thousands. Why can it run so many? Because GPU threads are extremely lightweight, not expensive like CPU threads. GPU threads are essentially a bunch of workers queuing up for work. Whoever is idle immediately gets to work. Let me add one more point. Latency hiding. When a CPU hits slow memory, it relies on large caches and out-of-order execution to wait. GPUs are different. Their approach is, I'm not going to wait. I'll just switch to another thread. Because a GPU has thousands upon thousands of threads. When one thread is waiting for data, it immediately swaps in another batch of threads to keep computing. That's why GPUs don't need caches as large as CPUs. It uses massive multi-threading to hide latency. So why are GPUs bad at logic? This is a very important point. GPUs are powerful, but they have one weakness. They hate it when different threads do different things. For example, in code you write, if x is greater than 0, do A, otherwise do B. If half the threads go to A and half go to B, the GPU's efficiency collapses. Because what GPUs really love is when everyone does the same thing together. This is called SIMD, single instruction, multiple data. One instruction processing lots of data. So GPUs are great for image processing, video encoding, matrix math, AI training, because the essence of these tasks is massive repetitive computation. Back to the earlier example, How does a GPU draw the game world? Now we get to the most classic part, rendering. Everything you see in a game, characters, maps, lighting, explosions, water reflections, ultimately turns into pixels. The GPU goes through a pipeline. Step 1. Vertex shader. Determine where each model is in the world. Step 2. Rasterization. Turn triangles into actual pixels. Step 3. Fragment shader. Color each pixel. Brighter here, darker there, shadows, reflections, all of it. In the end, millions of pixels are completely processed within 16 milliseconds. One frame appears, then the next frame starts over. 60 times per second, or even 144 times. Now we come to the AI era. Why did GPUs suddenly take over AI? Because people discovered something ridiculous. Neural networks are an amazing fit for GPUs. Why? Because the core operation in AI training is matrix multiplication. C equals A times B. At heart, it's just a huge number of repeated multiplications and additions. For a CPU, that's tiring. For a GPU, it's pure heaven. Because a GPU loves nothing more than repeating the same calculation millions of times. And so, the GPU, originally designed for gaming, suddenly became the engine of the AI world. And modern GPUs have even added dedicated hardware, tensor cores for accelerating matrix math, RT cores for ray tracing. This is also why today the company that truly dominates the AI industry is not a traditional CPU company, it's NVIDIA. Because more than a decade ago, they had already built the machine best suited for parallel computing. Many people initially think that the CPU is the brain of the computer. But later you realize that the entire modern computing world is a collaboration of different processors. The CPU is responsible for thinking. The GPU is responsible for large-scale execution. The CPU is like a scientist. The GPU is like an entire industrial city. One invents, one mass produces. And the arrival of it, I turned the GPU from a gaming accessory into one of the most important computing devices of a new era. So a GPU has never been a faster CPU. It's a different civilization, a different philosophy of computing, a machine that pushes processing massive amounts of data at the same time to its extreme. Next time you fire up a game or run an AI model, the GPU inside your computer might be running hundreds of thousands of threads simultaneously, processing millions of pixels, doing billions of calculations. And all that happens in just a few milliseconds.